Hello and welcome to Algebra 2, Chapter 8.5, and today we're going to be discussing some properties of logarithms. So first of all, here are our three properties. Okay, so we need to make sure we have these written down. The first one is a product property, and it says if you have log base b of a product, that you can split this apart, you can split the product up, and then you actually have the sum of the two parts of the product, so log base b of u plus log base b of v. So similarly, if we have log base b of a quotient, we can split it up as well and have log base b of u minus log base b of v. And anytime that we have log base b of u to an exponent, that exponent can pop around to the front as a coefficient. So what we're going to be doing today is we're going to do what's called condensing and expanding logarithms. And so this side would be the condensed form, this is the expanded form. So if you have one, then we can go to the other. And what this really does is it will help you to solve logarithms that can be expanded into parts that we can take the logarithms of. Alright, so use the property of logarithms to evaluate these expressions. So the first one, because there's a product, I can use my product property of logarithms, and I can write this log base 2 of 4 plus log base 2 of 16. And then if you evaluate these separately, this first one is 2 to what power is 4, and that is 2. And the second one is 2 to what power is 16, and that is 4, and we get 6. So this next one uses an exponent, which is going to be that power property, the third one. Power property. So this says that I can write it negative 2 times ln e. Okay, and then just a little refresher for remember, ln is log base e of e, which would mean e to what power is e. That is to the first power, so you get negative 2 times 1, which is negative 2. Alright, so let's look at two more here. So hopefully you know what 5 to what power is 125, but let's say you didn't or you couldn't remember. So what this property tells us is if we can actually write this, let's say log base 5 of 25 times 5, okay, that would be 125 still. That then we can split this up into the log base 5 of 25 plus log base 5 of 5. So from the first one, 5 to what power is 25? It's 5 squared. And the second one, 5 to what power is 5? The first power, and then we get 3. Alright, so for the second one here, we can do several things. First of all, if there's an exponent, where does it go? Goes around to the front, so this is 3 log. Alright, so 0.01. I find it easier to think about these in terms of fractions. So what fraction is 0.01? It's 100th. And remember, when there's no base, that it implies base 10. So if you look at this part, 10 to what power is 100th? Should be negative 2, because it's 2 because you did 10 to 100, so it would be squared. And the negative made it drop to the bottom, so this is negative 2 times 3 for negative 6. Alright, so everything we've done so far, we could find the log of just based off of what we know about some certain powers. But we can't always do that. We don't have enough of them memorized. And so if we're dealing with here log base 9, I don't know 9 to what power is 5 or 9 to what power is 11. And so we're going to use these approximations. So we have that log base 9 of 5 is approximately 0.732, and log base 9 of 11 is approximately 1.091. And so if we use our properties to split this apart, okay, so if I have a quotient, then I can split this up into subtraction. And so you need to make sure that you're using your properties here. We need to make sure we're writing them in correctly. So log base 9 of 5 minus log base 9 of 11. So this is the quotient property. Well, we know log base 9 of 5 is 0.732 minus, we know log base 9 of 11 is 1.091. And if we subtract those two, we get negative 0.359. So looking at the next one here, I don't know what log base 9 of 55 is, and it doesn't even tell me what log base 9 of 55 is. So what happens though if we write this log base 9 of 5 times 11? Because I know those where I don't know 55. So then if we expand this into log base 9 of 5 plus log base 9 of 11. So see how we're going to work towards what we know here. So then we can do some substitution, and this is 0.732 plus 1.091. For a grand total of 1.823. Okay. And we don't have to use both sets of information they give us. So in this last one, I don't know what log base 9 of 25 is, but if I split this up into log base 9 of 5 times 5, okay, so you could do what we just did up here and do log base 9 of 5 plus log base 9 of 5, but let me show you something else though here. What about log base 9 of 5 squared? That's what 25 is, or 5 times 5, which becomes 2 log base 9 of 5. So then we get 2 times 0.732. $1.464. Okay, so just really making sure you understand these three properties. Alright, so we've been expanding without really calling it expanding. We've just been expanding some, but we're going to expand a little more here. So we have a very condensed logarithm, and we want to expand it. And the first thing you're going to address is that division bar in the middle, and when we expand it, that means we're doing what operation? We're going to subtract. So we're going to have log base 7 of y minus log base 7 of 3x squared. Okay, now you can't address the power yet because that power only goes to the x, not the 3x. And so, but if I have a product, I can expand that further. So this is going to become log base 7 of y minus, I'll put parentheses there because I'm subtracting this whole thing, log base 7 of 3 plus log base 7 of x squared. Okay, and then you can do one of two things. You can go ahead and distribute that minus sign, or you can take care of the two, or you can do them both at once. I'm going to go ahead, distribute the minus sign, so minus log base 7 of 3 minus log base 7 of x squared, and then go one more step to address, because I can expand that a little further there, log base 7 of y minus log base 7 of 3 minus 2 log base 7 of x, and that then is completely expanded. So the next thing we want to look at then is condensing. And I would definitely start with these coefficients out front, okay? So this is going to become log base 3 of 7 squared minus log base 3 of x to the 5th. And then because they're both log base 3's and we are subtracting, then we can go ahead and bring this together into log base 3 of 7 squared over x to the 5th. And let's do one more step and make this log base 3 of 49 over x to the 5th. Alright, so another one to condense. Okay, so I would definitely start with your coefficients. And so this is going to be log base 8 of x squared minus log base 8 of 5 minus log base 8 of y cubed. Okay, and then just looking at those first two, since we're subtracting, we're going to have log base 8 of x squared over 5 minus log base 8 of y cubed. Now this can get to looking a little tricky, but what you're doing again is you're dividing. Alright, so this is going to become log base 8 of x squared over 5 over y cubed. Okay, but I'm not going to leave it like that, because essentially what I have is a fraction divided by a fraction. If you remember how you multiply, or how you divide fractions, you multiply by the reciprocal. So this part becomes x squared over 5 times 1 over y cubed. So multiply straight across. Alright, so then that leaves us with log base 8 of x squared over 5y cubed. There we go. Okay, so the next thing we need to address is how do I really get a number out of some of these? You know, the one with the log base 9 of 5 and the log base 9 of 11, it told us what those decimal approximations were. How do I find those if it doesn't tell me? And so this is called your change of base formula, and this is a very important formula. And so what it is you can take any base whatsoever, so base C, whatever that is, to figure out the decimal value of this log base C of u, you do log base B of u over log base B of C. And the deal with B is that B can be anything. It can be 2, 3, 10, 20, E. It can be anything. And so the nice thing is then your calculator can compute it if you make it either log base 10s. So right here, these are log base 10s. Or you make it log base E's. So the change of base formula says you can change it to whatever base you want as long as those bases are the same. So in your calculator, we can just use log and it would be log base 10, or we can use ln and it would be log base e. And both times those bases would be the same. So this is your change of base formula. Alright, so here's how we use our log base formula. So log base 4 of 8, which 4 to what power is 8? I don't know. So you can do this one of two ways. You can do it with a common logarithm, which would be log of 8 divided by log of 4. And so in this case, we've done log base 10 if you're just doing logs. And so then in your calculator, all you need to do is type log 8 in your parentheses if it started it, divided by log 4, and you get 1.5. Okay. At the same time, we can use natural logarithms, which is your ln. So we can do ln 8 divided by ln 4. And so try that out in your calculator. And we get 1.5. So it doesn't matter which base you use. In fact, if you could figure out a way to make them base 2 or base 5, it does not matter what base you use. As long as those bases are the same, you'll get that answer. Alright, so evaluate log base 6 of 15 using natural logarithms. So this is your ln. So this would be ln 15 over ln 6. And we're just going to type that into your calculator. And let's round to 3 decimals. 1.511. All right, that is what I have for you for 8.5. As a reward, kind of, for those of you that do take the time to watch the videos, because I really do appreciate it, a way to earn some extra credit. What we've had so far this chapter is lots of properties. And if you would, on a 3x5 note card, write down all of the properties that we've had for this, let's do all of the properties and formulas we've had for this chapter. You might leave a little bit of room because there's a few more still to come. But definitely from today you have your change of base formula and your 3 properties for logarithms. From the beginning of logarithms, we have how to convert logarithms to exponential form. And from before that, exponential growth and decay, and your equations for compound interest, continually compounded interest, exponential growth factors, and exponential decay factors. So if you would write all of those on a note card and show me by the day that we do this video in class, I will give you some extra credit for that. So I hope you have a great day. Let me know if you have any questions, and we'll see you in class.